Hello, this is Jeremy with Healing Vectors LLC. So, today we are going to cover a tutorial, right, through Qiskit. This is just an algorithms tutorial. Now, I recently took the IBM's Fundamentals of Quantum Certification test. So that test is based on Qiskit 0.2. The problem with that, it's been deprecated, so the code that test is going to be on isn't even being used by IBM right now. Maybe in some of their legacy systems, if anything, but for the most part, it's not going to be used. There are a couple of things that the test covers that you might want to check out. Here is let's see. So I'll post this link for y'all. Right. This is the basically 0.19 Qiskit. So if you want to go through this documentation and get certified through it, that's where you'd want to go. I'll post a link to all this for you in the video. So you have that, and then also check out the training certification. It's about $200. You can also get this test for free, which is pretty cool. That's how I took it. I basically, IBM gave me a sponsorship for it, and it was pretty difficult. Make sure you go through all this. Focus on the majority, constructing quantum registers, using single qubit gates, multi-qubit gates, and what they mean. There is a way to take this certification for free, so definitely check that out. And I have a bunch of slides and things like that as well. Some of the issues I had on my test was with the gates, not really, knowing what the gates do. So I have a couple of mathematical representations that I found for them that I'll share with y'all here. And let's see. So, this is a matrix representation of an X gate. Right. This will probably be on the test. I can't guarantee that it'll be on the test, but it'll probably be on the test. What it looks like, kind of. When you print it. This is how it's represented mathematically. A matrix is a two-dimensional data object made of m rows and n columns, therefore having a total of m times n values. If most of the elements of the matrix have a zero value, then it is called a sparse matrix. Example of an X gate. This is a code example, right? So if you wanted to see this, let's go say 3. And 0. And then QC.draw. Quantum circuit. Am I spelling that wrong? Oh, silly me. I haven't imported anything yet. Let's try down here. Looking at some of my old code. Nope. And try that again. How is that not defined? Clearly defining it right there. It's not drawing anything. Weird. I guess they changed, so it used to be where it would like double print this, and now it's not. So why isn't it working here? Of course it's defined. I'm literally defining it there. And if you know why I'm getting that error, or if you have any guesses, definitely let me know in the comments below. So let's go over this. An introduction to algorithms in Qiskit. How is an algorithm library structured? Right. Basically, they have an entire library of different algorithms that we can use, and here we will be experimenting with the VQE. So check out the documentation. It's definitely helpful. Right. Some of the parameters we'll be covering in this section will be the announce and the optimizer, and then the quantum instance. So yeah, pretty good stuff there. With the VQE, it's a pretty versatile algorithm, so it means you can take a lot of different things, and in classical optimizer, and it has a variational form, which is trial wave function. Cool. Quantum circuit, which apparently didn't want to work for me here, which is weird. Alright. Okay, so let's go over it. Right, I added a bunch of imports to this. You don't have to. I was just trying to troubleshoot my code, even though my code should work here too. I don't understand why it didn't, because I was defining QC, or quantum circuit, as QC, so maybe I got it backwards. No, it wouldn't have worked on the other one. It wouldn't have worked here. It's hilarious. Okay, well, it's working now. I don't know if it was like it just wasn't passing the variable correctly or not, but there you go, that's what would have happened. Surprise, surprise, I do know what I'm talking about. Hells yeah. Now let's draw the announce so that, let's see your quantum circuit where theta position 0 through theta position 7. What is that? Theta 0. I don't know what this bracket means. I should probably learn now. Will be the parameters that are varied. As the VQE optimizer finds the minimum eigenvalue, we'll come back to the parameters later in the working example. So they draw the announced for us. We're gonna take this out just because it might mess with the code later on. And then we'll run this again. Right. This is basically calling the backend because we need to run the algorithm on a backend. We're going to be using Air simulator state, or Air state vector. That's what that is. And then we're also going to be using quantum instance. This is for the optimizer, and we're going to be taking a look at a water molecule, so H2. Let's put what we've learned together above in a working example. VQE to find the minimum eigenvalue, minimum energy value of Hamiltonian operator, and hence we need such an operator for the VQE to work with, right? Such an operator is given below. Originally created by nature application molecule as the Hamiltonian for H2 molecule at 0.358 interatomic distance. That's the sum of poly terms below. Cool. So that's what this is. Hydrogen 2. and its mathematical representation so that we can input it to the code. So let's build an VQE instance passing a backend using quantum instance to the constructor. Now VQE does have setters so that quantum instance can also be passed later. In order to do that, I need to learn this notebook, and we'll see the exact same value with the global algorithms, global transpiler simulator, quantum instance. Bing, bada, boom. Optimal value. From the above results, we can see it took optimizer 65 evaluations of parameter values until it found the minimum eigenvalue, negative 1.85727. Sweet. Using VQE setting quantum instance after construction to close off, let's also create an instance without supplying the the VQE instance without supplying the quantum instance. We later said as long as the VQE runs, it has a quantum instance to use. Right? Get the same. So the identical seeding was used prior to the example. This is pretty much just a little tutorial for it. Right. So that was a cool little video. We did cover some troubleshooting. Right. Here's a little cheat sheet for when you're actually trying to, do a bunch of things with it. Plot histograms, that's actually on the exam. So check it out. The exam is a great way to learn. Even if you don't pass it, because then they'll tell you like what your weak points are, and then you can actually focus on your weak points. The certification may or may not be worth it. It just really depends. I don't know of how many people are actually hiring based off of certifications. I have a bunch of certifications in technology like Google IT and JavaScript, Python from like LinkedIn, things like that. So I know a lot of things. I am setting up a book, so definitely check that out. So I'm actually writing a book. This is the cover. It'll be pretty cool, It's like a little repairman for the world, because it's gonna take a lot. And then some other things that the Qiskit exam covered, Y gates, S gates, T gates, Z gates, bunch of other things, state vector simulator, unitary simulator, chasm simulator, so you want to know all those, right? Qiskit Terra as well. It did cover a lot of that. Excuse me. Yeah, so it is a closed textbook certification test. I am not a fan of those because, it's in real life you'll never not be able to look up the answer. Like, if you're a programmer, you can look up the answer for almost anything pretty fast. I guess they want you to have the knowledge more than just be able to look up answers, which I can understand in one point, and the other point, if it takes you 2 minutes to look up something and you can answer in 2 minutes, it really shouldn't count against you. That's my point of view. some of these links I will provide if you're having, like, if you need to, look at a Python refresher, because most of this is all Python. Definitely study it. Aside from that, these are just a bunch of different links that I think would help. So yeah, and then there's the study guide, which is this study guide. Definitely check all this out, and keep joining me for these streams. I'll try and set them up every Wednesday and Friday. If I can't, it'll just be a Wednesday or Friday, just because I'm pretty busy writing the book and creating the class right now. But we'll get through this. I'm glad you joined me on this adventure. It's quantum random access memory. And I'll see you next time.